As a freestyle dancer of 13 plus years, I find immense joy in witnessing the capabilities of the human body in motion. It makes me wonder what's happening inside our muscles that allows them to move dynamically yet smoothly. I understand movement begins with contraction, but how does a muscle contract? Well, muscle contraction begins with electrical signals from our nerves, triggering calcium release within our muscle fibers. So, what's going on in there? And like, what is moving, sliding? What's allowing? What substances are allowing the muscles to contract? Well, like keys unlocking doors, calcium enables actin and myosin filaments to slide together. Myosin pulls actin to shorten sarcomeres, the fundamental contractile units of our muscles. When millions contract in unison, boom, immense force. Now that our muscles are moving, though, what keeps them going? Well, to keep moving, cells utilize bioenergetic systems, such as utilizing phosphocreatine stores, glycolysis, and cellular respiration to break down substances and derive more ATP, which is the energy. So, what steps are responsible if you decide to sprint for all out 10 seconds? Well, first, you use phosphocreatine stores, which are great for short bursts at full intensity, but these last only seconds before they deplete, about 10 seconds. Why can't you keep up the intensity? Well, as intensity ramps up through byproducts, they accumulate faster than oxygen can be utilized. So, higher intensities rely more on rapid glycolysis because trading the lower ATP output will allow the bioenergetic system to keep up with the demand of the exercise. So, how does this change as you recover and jog for 4 minutes? Well, given the oxygen usage in the jogging for 4 minutes, pyruvate from glycolysis then feeds into the mitochondria within the muscle fibers for oxidative respiration, pumping out far greater energy yields to fuel hours of activity. What is the body doing to make all this possible? Well, the catch is that these energy systems are constrained by oxygen and glucose delivery. This whole time, they're trying to balance the two and deliver it in our body to supply energy to keep up this exercise and this demand. As I dance more vigorously, my muscles require more blood flow. My heart rate rises to shuttle oxygen to working cells, but I eventually hit a cardiac output limit. Only so much blood can be pumped each minute, and no matter how much I love dance, fatigue sets in. So, you feel your heart rate increasing when you do aerobic exercise. What's going on when that happens? Well, aerobic exercise is supposed to train the cardiopulmonary system to enhance delivery of oxygen and other energy substrates to various parts of your body. Increased demand for oxygen in the working muscles requires the heart to pump more blood quicker to help restore balance of substrates in the body. So, doing that aerobic exercise is going to elevate that heart rate. So, why is it elevated? Our breathing rate heightens thanks to the rising CO2 levels to try and blow off the accumulating acidosis. Heart rate surges to increase overall blood delivery to the muscles in need. So, is that helping? Well, nerve cells are sent to raise the heart rate and the stroke volume, which overall increases the cardiac output to supply the active tissues. So, it's keeping you alive. So, you're wondering why you're sweaty or feel out of breath? Maybe you think it's because your oxygen saturation dropped? Well, you may feel sweaty as a result of the body's cooling mechanism to move away heat in the form of evaporation. And you may also feel out of breath due to the imbalances of CO2 and oxygen levels being temporarily overwhelmed with CO2 and the lack of oxygen. So, all of this is being experienced to supply ATP substrates and to cool the rising temperatures in the body. Basically, everything that needs to happen to keep you going. So, I gave you a great workout and it's been 24 hours later and now you're feeling sore. What's going on here? Is it this thing called lactate? Well, actually, it's this thing called delayed onset muscle soreness, or DOMS for short. Pushing the limits leads to small tears or trauma within muscle fibers themselves. Inflammation kicks off 24 to 48 hours later, sensitizing pain receptors that were previously numbed by intense workout highs. The lactic acid was once blamed, but lactate actually converts back to pyruvate without issue after catching breath, or like as soon as like you start to regain the oxygen levels. So the true source is simply muscle damage and inflammatory response. This muscle breakdown is part of the training stimulus that drives beneficial adaptations over time. Consistently taxing limits prompts physiological restructuring to better handle more intense dancing, more intense thresholds of exercise. Skeletal muscle fibers grow larger and increase in number, boosting strength and resistance to fatigue. More mitochondria build within the cells too, expanding the aerobic capacity. So we've trained together for 4 months. Why are you able to perform 25 push ups when you could only do five at first? You're able to run a mile under 10 minutes when before you could only do 15. Well, these remarkable changes come from physiological adaptations. Consistent training drives skeletal muscle fibers to increase in size and number. This hypertrophy lets dancers lift legs higher, resist fatigue when repeating complex sequences. We enhance the powerhouse of the cells too. More mitochondria build up to utilize oxygen to fuel longer routines. So your VO2 max is now 45 milliliters per kilogram per minute. Is that good? Yeah, that's pretty good. All that aerobic work expands heart volume and efficiency, and forcing ventilation adapts the cardiopulmonary system to take in and transport more oxygen. So that number is relatively good compared to average numbers. Is VO2 max the only thing you should care about though? While VO2 max sets helpful baseline metrics for cardiorespiratory fitness benchmarks, overall health is beyond this one number. Monitor flexibility through full ranges of motion, appropriate body fat percentage, normal blood markers like cholesterol, glucose control, and low resting blood pressure as well. All will contribute to the ultimate goal of sustaining consistent physical activity for lifelong gains. And that does not require pushing VO2 max limits unless you're training for a competition. So just remember, moderately stressing multiple systems provides better general disease reduction and longevity returns for time invested.